This is called the unit circle, and the unit circle has a radius of 1. We have another definition of trig functions that involves a unit circle. So let's write those out. You'll find these in your book also. And in the book, instead of using theta for this trig definition, they use t. So we're going to say the sine of t is equal to y on the unit circle. The cosine of t is equal to x, and the tangent of t is equal to the ratio of y over x. And then that's our 3 trig functions, and then we have their inverses. So cosecant of t would be 1 over y. Secant of t would be 1 over x, and cotangent of t would be x over y. And there's some stipulations where you can't have 0 in the denominator, so like in the tangent and the secant, x cannot equal 0, and then the y cannot equal 0 for cotangent and cosecant. So the unit circle has a radius of 1, meaning that when we talked about this, our r here would be 1, so this would be 1 squared or just 1. So now if it asks you to find the sine of pi over 3, you can look at the unit circle and you can say, well, the sine of any angle that's on the unit circle, and this one is equal to y. So that means if I go to my unit circle, where is pi over 3? It's right here. And so we're talking about this angle here, and the y value is the square root of 3 over 2. So I'm going to write that down here. Square root of 3 over 2 is my answer for that. So this makes it much simpler to do these problems. And then, so you can have angles that fall in quadrant 1. You can have angles that fall in quadrant 2, 3, or 4, or even angles that fall on the x and y axis. Those are quadrantal angles. So if it had asked you this, write some problems here. Let's say it said to find the cosine of pi over 2. Well, the cosine on the unit circle is the x value. So when I go back to my unit circle, I look for pi over 2. It's right here. And the x value there is 0. So my answer here would be 0. Let's try a few more. What if it said the tangent of 2 pi over 3? So we'll go to the unit circle. And we'll look at 2 pi over 3. 2 pi over 3 is here. And notice all the degree measures are on here too, so you can use this unit circle for that also. And so the tangent of 2 pi over 3 is equal to the y over x ratio. So the square root of 3 over 2 is my y, and negative 1/2 is my x. So I'll calculate this ratio. So let's go to the whiteboard and do that. So it will be square root of 3 over 2 divided by negative 1/2, which I'm going to write like this. Because if I write it like this, then I can see what I'll do is when I divide a fraction, I keep the first fraction the same, and I flip and multiply the second. So I flip this to negative 2 over 1. The 2's will divide out, leaving me with negative square root of 3 over 1, which is just negative square root of 3 is my answer. So the tangent of 2 pi over 3 is negative square root of 3. And then remember, that is, we have to have, when we talked about this previously, the quadrants, we have to have quadrant 1 is going to be all the trig functions are positive. So no matter what you calculate here, you're going to get a positive answer. In quadrant 2, only the sine and cosecant are positive. So notice when we got tangent, we got a negative value, negative square root of 3. In quadrant 3, tangent and cotangent are positive. The other 4 are going to be negative. And in quadrant 4, you've got cosine and its reciprocal are positive, and the other 4 are negative. So when you calculate this, you also want to check and make sure that those signs calculated correctly. But using the unit circle, you're going to find is one of the easier ways to calculate the trig functions. Now, having this unit circle memorized or created is another process. So let's take a look at how we can do a unit circle and make it and being able to fill it in from scratch. So if you needed to draw this on a piece of paper, how could you do it? So here I have a blank unit circle, and we're going to fill this in. So the first thing I'm going to do is fill in the angles. So I know this is 0, this is 90, this is 180, and 270, and then back here will be 360 degrees. Oops, there. I also know that I have the 30, 45, and 60 angles in each quadrant. And that's in reference to the x-axis. So this would be 30 degrees away from 180. This would be 45 degrees away from 180. This would be 60 degrees away from 180. And the same thing here, and the same thing here. So this would be 210, so 30 degrees more. This would be 225 or 45 degrees more. This would be 240 or 60 degrees more. This is 60 degrees less. This is 45 degrees less. And this is 30 degrees less. And then I also have, I can convert these to radian measures. Now, for the radians, we've got 0, we've got pi over 2. These you kind of have to have memorized. We've got pi, and then we've got 3 pi over 2, and we've got 2 pi. So now, to talk about the rest of these, everything that is 30 degrees away from the x-axis has a denominator of 6. I'm going to put those in and radian measure. And then everything that is 45 degrees away from the x-axis has a denominator of 4. And everything that is 60 degrees away has a denominator of 3. So we've got the denominators in the radian measure. Now you could take this and convert it, right? You can convert from degrees to radians by multiplying by pi over 180. This is going to take you longer to do. I'm trying to show you some shortcuts. So all of these numbers have, and I'm using this little bar here as the fraction bar, all of these have a numerator of pi. And then over here, we've got pi is the 180. So this is really close. If you think, what is a denominator of 6? If you were to say, it would be 6 pi over 6, but this is just one less, so 5. And then we've got 2 pi over 4, and we've got 2 pi over 3. One more than 6 pi over 6 would be 7 pi over 6. And then over on this one, 2 pi over 2 pi with a denominator 6 would be the same as 12 pi. So one less would be 11 pi. And then we've got 7 pi over 4, and we've got 5 pi over 3. Over on this side, we've got 5 pi over 4, and we've got 4 pi over 3. You can kind of see, you can see that this is pi over 3, 2 pi over 3, then we've got, this would be 3 pi over 3, you get 4 pi over 3, and 5 pi over 3. So you've got sort of, you can see a little bit of a pattern there of those. So those are all the radian measures. Now let's fill in the x and y. So the ones that are on the quadrantal angles, these are easy to memorize. You've got 1, 0. This point here would be 1, 0, 1 on the x, 0 on the y. Here again, we've got 0 on the y. This is negative 1. On these two, you've got 0 on the x, but you've got negative 1 and you've got positive 1. So I filled in those. Then everything else, all of these have denominators of 2. So let's put denominators of 2 on all of them. And I'm going to use that black line that's there as fraction bars. Now, in the first quadrant, you're going to write the x values, 3, 2, 1, and the y values, 3, 2, 1. And then everything gets a square root. The only thing is, when you take the square root of 1, it's just 1, so I don't have to put it there. And then going this way, you've got the x values, 1, 2, 3, and everything gets a square root. And you've got 1, 2, 3, and everything gets a square root. And you have to put in some positive and negative signs because here you've got everything positive. So all and all. Here you have just sine and cosine, which means the y, I'm sorry, the y value, I put the wrong thing here. It should be cosecant. I meant to write the reciprocal. So the y value is positive, but the x value is negative. Here, again, we're going to do the 1, 2, 3 thing. So it's 3, 2, 1 though. And this is 1, 2, 3. Now I want to also show you, I'm going to show you, this is both, everything is negative here. Tangent is positive and cotangent. Everything else is negative. The x and the y values are negative because when you divide the two together, you're going to get a positive value. And then we've got 1, 2, 3 here, and 1, 2, 3 this way. Everything gets the square root, and I forgot to put that over here. Okay, so, and then the last thing I want to show you, also, this is cosine and secant are positive, so then all the y values are negative. And so I highlighted all the reference angles in each quadrant have the same values, so just positive and negative.